Okay, so this week, one of the things you're learning is factoring. And it's a very, very important skill because you will be using it pretty much every week going forward. And so one of the topics on factoring is factoring perfect square trinomials. So let's start with what is factoring. So we have to understand what a factor is because factoring is, has factor as the root. So a factor is a number or quantity that when multiplied with another produces a given number or expression. What this is saying, if I can get my pen working, is that if I multiply two numbers together, like 3 times 5, that gives me, 3 times 5 gives me 15. 3 and 5 are factors of 15. So another way that you can think of factors is it divides evenly into something, or there's no remainder when you divide it. So things that you can multiply by something and get another number. So 3 and 5 are both factors of 15. And there's more than one factor of 15 or more than two because 1 and 15 also are factors of 15. So factoring is taking something that's been multiplied and you're splitting it up and now you're writing it as multiplication. So factoring would be to take something like 15 and instead write it as 3 times 5. So it's not something that we often do with numbers, although we do something like that on the way to factoring, but factoring is generally used when we talk about polynomials. So we've got variables going on. And so it's basically undoing multiplication of polynomials. So if you have things that you used FOIL on that you multiplied them together, it undoes that operation. So factoring reverses it and it turns a polynomial into its factors or things that are multiplied together. So we are going to be focusing on a specific type of polynomial that is called a trinomial, where you've got 3 terms. That's what makes it a trinomial. So tri is 3. And so you've got 3 terms. You can think of nomial as basically a term. And we usually focus quadratics where the exponent is 2, though you can use this method on things that don't always have an exponent of 2. But that's the most common one when we're talking about factoring trinomials, as we're talking about things with a squared term. And these always factor into a product of 2 binomials when you have something that's x squared, because x times x gets you x squared. So when you undo it, you're going to have 2 things that are linear, basically, that have an x in them. So these usually factor as 2 sets of parentheses, and you'll have something with an x plus or minus another number, and then something with an x plus or minus another number after that. So when we're factoring a trinomial, that's generally the form that it's going to go into. It's basically reversing FOIL. So there are 3 basic ways that you can factor something like this. The first is the trial and error method, and that is used basically when your coefficient of the x squared term is 1, because there's not as many choices. There's the AC method, which is best when it's not 1, because you have a lot more choices when you're trying to do guess and check. So AC is usually better. And then we've got formulas that you can use for factoring. And these are for special cases when they're in specific forms where there's a formula to undo it. And so what I'm focusing on today is one of the special cases, which is a perfect square trinomial. So that's where I'm going to be focusing, is how to factor this particular special case. And it's useful to recognize these special cases because this shows up when you learn about completing the square. When you're completing the square, you're creating perfect square trinomials. And so it's helpful in future things that we will be doing. So a perfect square trinomial is in one of the following 2 forms, and they look nearly identical except for the sign of the middle term. So you've got something squared, which we're just calling A, but it could be anything, plus 2 times that thing that was squared times another thing, and then plus that last thing squared. So that's one of them, and then the other one has a minus. But the key is that, and this is how you identify you have a perfect square trinomial, is that your first and last terms are perfect squares and they're positive. So you don't have like a negative in front of them. And when we say perfect square, that means you can take the square root of it. So that's what it means by perfect square. And that's where the name perfect square trinomial comes from. So when I say you can take the square root, that means there's no, when you do it, it's going to come out whole. There's not going to be any decimals. There's not going to be things left underneath your radical. That's why we had to learn, we learned how to kind of take square roots. As you're able to do it on your calculator, you get like a whole number kind of thing. So the first and last terms you have to be able to take the square root of, and they're positive. The middle term needs to be a multiple of 2 because the formula has 2 times this thing. So you have to be able to divide the middle term by 2. That's how you know it's a multiple of 2. And then when you divide it by 2, that answer is the multiplication of the square roots of the first 2 parts. So you have to kind of go through this process to recognize whether it fits into a perfect square trinomial. And then once you recognize that it is, then there's a formula that we can use to actually factor it. And we use the results of what we did by determining if it's a perfect square trinomial. We use that to factor. So it's not like you're just doing this work and then you don't need it. It's actually going to be helpful. So when you have recognized that you have one of these, it factors into what we call a square of a binomial, where you've got a binomial, which is 2 terms, and then it's squared. And so the version that has the positive in the middle term factors where you've got a plus, and then the version with the negative for that middle term factors where you've got a minus, but they're nearly identical. And the a plus b squared or the a minus b squared, that's the same thing as just writing it twice, because we've learned about exponents. If you something times something, it's an exponent of 2. So if you didn't recognize that if this is that it's a perfect square trinomial, you can go through factoring using the other 2 methods, trial and error or the AC method. And when you go through it with those methods, you're going to see that when you factor, you get 2 identical things. So it will look slightly different when you factor it using trial and error and AC method versus doing the formula for the perfect square trinomial, but they are equivalent. They mean the same thing. And whenever we're factoring these, we always factor out the greatest common factor first, and then you go from there. That's whenever you're factoring, that's the first thing, is you want to factor out the greatest common factor. So we're going to do a couple where we're going to factor with one of the other methods for factoring and then use the formula, so you can see how you basically get the same thing and you can kind of compare, see which method you prefer. So we've got x squared plus 10x plus 25. Because the coefficient of the x squared is 1, this is easily done by trial and error. And so when you're factoring by trial and error, you have your starting point, which is your polynomial. And then you basically set up your 2 sets of parentheses. And we're undoing FOIL here. So the first terms give you the x squared. So x times x gets you x squared. So you know that those are going to be x's. The last terms give you 25. So you know that it's 2 numbers that multiply to 25. And this is where you may have some choices. Like 25 is 5 times 5, or it's 1 times 25. So you have 2 choices here. on possibilities that multiply to 25. And so you're going to have to pick one of those, where those are the ones forming your last term. And then when you're doing FOIL, the inside and the outside, those add together to get you the middle term, the 10. So when you're looking at these, you're looking for two numbers that will multiply to 25, and then they're going to add together to get you 10. Because when you're multiplying by an X, you're just multiplying by 1. So our only choice here are the two 5s. 5 times 5 gives you 25. 5 plus 5 gives you 10. So those are both positive 5s. So you're going to fill this in with a plus 5. And then if you want to double check your answer, you can go through FOIL. You multiply the first terms. X times X is X squared. Then outside terms for the O is X times 5. So that's 5X. Then inside terms, we have 5 times X. So that's 5X. And then the last terms is 5 times 5, which is 25. So when you simplify, you get X squared plus 10X plus 25. So you've just verified that this is correct. So your actual answer is the parts that are in parentheses here. This is your answer for the factoring. And that's trial and error. So you're kind of thinking through FOIL and undoing that process. Now, this is a perfect square trinomial because we got the same thing in each sets of parentheses there. So that indicates that it's basically X plus 5 squared. So we can also use the formula to factor this. And you do this by first checking by, the formula. Does it follow our formula? So first I'm going to start with rewriting it again. I got X squared plus 10X plus 25. So to recognize that we have a perfect square trinomial, your first term and your last term need to be things that are squared, or that you can take the square root of. So we already have X squared. Obviously, that's squared. So the first term is squared. The 25 is equal to 5 squared. So I can rewrite that as 5 squared. So the first bullet point, that the first and the last have to be perfect squares, or things you can take the square root of, that's satisfied. So let me go back to my slide where I listed these. Second one, the middle term has to be able to be divided by 2. So our middle term is 10X. I can divide 10 by 2. So if I do that, if I'm basically factoring that, 10 divided by 2 is 5. So that would give me 2 times 5X. And then the third bullet point is that your middle term after you divide it by 2 is the multiplication of the square roots of the first and last term. So what this means is that after I divided by 2, I got 5X, and that is equal to this X and this 5. Those kind of get multiplied together to give me my 5X. And that's what makes it a perfect square trinomial, is that it's in this form where your first term or your last term are squared. The middle can be divided by 2. And when you factor that 2 out, you're left with the multiplication of the 2 outside bits. So when you recognize that, that is in the form that I have up here, a squared plus 2ab plus b squared. So a, in this case, is equal to X, and b is equal to 5. So once you have identified it's in this form, then you just use the formula, which is a plus b squared. And it's a plus here because our middle term is plus. And so a is equal to X, so it's X plus, and then b is 5. So we get X plus 5 squared. And so this is the same answer as what we got from trial and error. It's just with trial and error, you end up having it written twice. And when you use the formula, you write it once, but you indicate that it's squared. So you get the same answer. Whichever method you prefer kind of depends on how your brain works. I do encourage you to get familiar with the formula though and using the formula, because if you recognize that it's in this form, it does actually make it easier to factor and faster to factor. If you start making association between what it looks like factored and what the form is, it can speed up the trial and error process for you. Other questions? Okay. So I have another one here that I want to do two ways. And we're going to do the AC method on one way, and that's because the beginning here isn't 1. We have a 100 as our first term. So I would not do trial and error necessarily on this. And then I'm going to use the formula. In this case, the formula is slightly different. It's got the minus, and that's because the middle is negative in this case. So we'll start with the AC method. So we have 100 c squared minus 140 c plus 49. So you always first check to see if there's a greatest common factor to factor out. Whenever that first term has a coefficient that's not 1, check for a greatest common factor. There's nothing in common though here. I can't factor a number out of 100, 140, and 149. There's nothing that they have in common that I can divide them by. So the AC method has you take the first term, number 100, and the last term, number 49, and you multiply those together because that's A times C. So A times C would be 100 times 49. Which is 4,900. And then the way the AC method works is you're trying to find a combination of those that adds to the middle term, 140. So we're going to have to write down all the numbers that multiply to 4,900. And I have like a method that I do to do this. So I always start with 1. And then whatever my number is AC divided by 1, that's the other number. So the other number is 4,900. And then I do 2. So 4,900 divided by 2. So you will need your calculator for this. It's 2,450. And then I try to divide it by 3. And if you get a decimal, then you skip that. So I got a decimal. So then I try to divide 4,900 by 4. That came out to a whole number. So that's 4 times 1,225. Then you try to divide it by 5. That gives you a whole number. That's 5 times 980. Then divided by 6. That gave me a decimal. Divided by 7. Okay, so that gave me 7 times 700. Divided by 8, that gave me a decimal. Divided by 9 gave me a decimal. Of course, 10, because we used, that gives us 10 times 490. Then we divide by 11. That gave me a decimal. Divide by 12 gives me a decimal. Divide by 13 gives me a decimal. 14. Then I try divided by 15. And you may be wondering, well, how do I know when I keep trying? So on your calculator, if you take the square root of 4,900, that is 70. So I need to keep going until I basically checked all of the numbers up to 70, which is a lot. And this is one reason why, if you can recognize that you can do this by a perfect square trinomial, it's actually faster, because I need to check all of the numbers from 1 to 70 and write down all the combinations that multiply that go into it evenly until I find the right one that I need. And it's a long process. So we got 20, 245. A lot of these don't go into it evenly. Okay, so then we've got 25 and 196, because I'm running out of room here. $28 and $175. I'm just sitting here going through my calculator, because this is, I mean, you probably can't do it in your head. You're not going to know. Let's see, we've got 35 and 140. And going. So I'm looking for a combination as I go through these that's going to get to 141. And because we're multiplying to a positive and adding to a negative, both of the numbers are going to be negative. So the two numbers that I'm getting out of here, I need to make sure that they add together to get to 140. So none of these add to 140, but we're certainly getting closer. Yeah, 49 times 100. So that adds up to 149. So we're getting closer. We've got 50 and 98. That gives us 148. Oh, I just wrote the wrong number. You can see if you were on a time test and you were given one of these, this is taking a lot of time. And you wouldn't want to necessarily do this on a timed test if there is a faster way to do it, because it takes time, and that's valuable time that you don't want to waste. I should be getting close. Unless I skipped it. Okay, now I'm trying 70. Okay, and that it actually ends up being our last one here, 70 and 70. So 70 times 70 is 4,900. I've now checked every possible combination because the square root is 70. And then 70 plus 70 gives me 140. So that is finally the combination that we were looking for here. And that is what we're going to use for our AC method. So now that we have found our combination, and this did take a while, the AC method has you rewrite your middle term using those two numbers. So you write 100 c squared, and then instead of minus 140c, it's going to be minus 70c minus 70c. And then plus 49. So you're creating an extra term here. You're taking the middle, you're splitting it up, and this allows us to do grouping. So we're going to group the first two together and the last two together. And so you put them in parentheses to indicate that you are grouping them. And there's always a plus sign in between them. So basically that minus 70c gets turned into plus a negative 70c. And then you factor the greatest common factor out of each set of parentheses. So for the first pair, we have 170, and I can divide those both by 10. And then there's a c squared and a c, and I can divide them both by c because they both have a c in common. So I can factor out a 10c, which leaves me with 10c minus 7 when you divide that out. Now, the second pair is a negative 70c, and we always factor out a negative if that first part is negative. So I'm going to factor out a negative. And what 70 and 49 have in common is 7. So I can factor out a negative 7, but I can't factor out a c because they don't both have a c. So I'm going to factor out a negative 7. And when I divide them both by negative 7, I get 10c minus 7. So with the AC method, if you notice that inside your two sets of parentheses here, you have the same thing. Those get factored out as one of your sets of parentheses, 10c minus 7. And then the second set is the greatest common factors, which is also 10c minus 7. And so that is the result of the factoring. So I wasn't keeping time to see how long this example took, but having to go through all of the possibilities so you can figure out how you're splitting the middle term up in the particular way that you need to does take a while. So now let's do the same problem using the formula and the fact that this is a perfect square trinomial. So we have 100 c squared minus 140c plus 49. So we know that 100 is a perfect square. That's 10 squared, and we have a c squared. So this is 10c squared. So both the 10 and the c are squared. 49 is 7 squared. So the first and the last are perfect squares. The next thing we check is that we can divide the middle term by 2. So 140 does divide by 2. So when I divide that by 2, I get 70, or 70c, because we have a c there. And we want to check that that 70c, that middle term, is the first and the last essentially multiplied together. So we have 10c squared minus 2, and that 70c is made up from the 10c times 7. 10c times 7 gives us 70c. So this meets the format of the perfect square trinomial. So once you recognize that it's in the format, then you just have your A, which is the first part here, 10c, and in the formula we have b here, so that's going to be 7. And so when you factor, you just replace those. So our answer, it's a minus b squared, which is going to be 10c minus 7 squared. Oops. And that was much faster than doing the AC method. And that's one of the reasons why we have these shortcuts or these formulas, is because it can save you a lot of time depending on what you are factoring. So maybe it didn't save us any time with this particular problem, but it saved us a lot of time with this one because we had a lot of choices to go through. And if we recognized it was in this form sooner, then you can get it done really quickly. So are there any questions? Okay. Oh, go ahead.
Oh, sorry. With the back one, with the formula section, how did you go from the -2 times 10c times 7? Do we have to break that down again? Let's see, the third step down from the formula section.
So that was me verifying that it fits our formula here. -2 times A times B.
Perfect, got it. Okay.
Yeah, so the 10C, that is our A, and then the 7 is our B. So instead of writing 7DC, I was just verifying that it does. If you multiply your A and your B together, you do get that, that you can split it up that way.
Okay, understood. Thank you.
You're welcome. There are other questions? Okay. So now we're going to just factor these. Some of these we can factor this way, some we can't. So because you're not always going to be told that it is a perfect square trinomial and you can factor using these rules. So you have to kind of figure it out for yourself and then factor, depending on what you've got here. So I'm going to start with the one on the left. We've got 2a squared plus 14a plus 98. So as soon as that first term is not 1, it's got a number there, I need to see if there's a greatest common factor. So I can divide a 2 out of 2, 14, and 98. So that is our greatest common factor. And so when I divide each of the terms by 2, I got an a squared because I removed the 2. 14 divided by 2 is 7, so I get 7a. And then 98 divided by 2 is 49. So you get a squared plus 7a plus 49. So now you have something that you need to try to factor further. Whenever you've got something squared, you always want to try to factor further if possible. So I see that I've got something squared at the beginning, a squared. And I've got something squared at the end. I have 49. So far, it's looking like this could be a perfect square trinomial. So then the next step is you check the middle. Can I divide that middle number by 2? Well, 7 doesn't divide by 2. So because the middle doesn't divide by 2, this is not a perfect square trinomial. But that does not mean it's not factorable. It just means we can't use that particular method. And so that's where I would say, can I try trial and error? So if I try to just kind of write this, not divisible by 2. Hope if I spell that right. So not a perfect square trinomial. And so we want to trial and error, guess and check. So I know it's going to be a times a to get me to a squared. And then we want to multiply to 49. So the numbers that multiply to 49 are 1 times 49 and 7 times 7. And you want a combination that adds to 7. Well, the first one adds to 50. 1 plus 49 is 50. The next choice, if we try to use that, 7 plus 7 is 14. Neither of those add to 7. So what this means is that those are the only choices that multiply to 49. And we can't get a middle term of 7 out of there because those pairs of numbers don't add to 7. So that tells us that we can't factor this with trial and error. And if you can't do trial and error, if you've tried all of your choices and none of them work, that means that that particular part is considered prime. So a squared plus 7, well, let me do this in a different color. A squared plus 7a plus 49 is prime. But that doesn't mean that this is the whole polynomial is prime. We were still able to factor out a 2. So we were still able to factor, but we can only factor as far as factoring out the greatest common factor. So that is our final answer. And that is factored because we were able to make it into something times something else. We just couldn't factor for it. So it looked like it could have been a perfect square trinomial that we could have factored, but that one doesn't actually work because it doesn't meet the requirements. And then if you try to factor another way, it can't. And so then you kind of go back to where you were from there. So let's look at the second one here on the right. We've got 12x squared minus 12xy plus 3y squared. So again, I look to see if there's a greatest common factor that I can take out. So I can divide those both by all three parts by 3. I can factor out a 3. So 12 divided by 3 is 4. So that gives me 4x squared minus 4xy. And then plus I divided by 3. So that gives me just a y squared. And so now I'm looking at what's left in parentheses because it's got something squared. We need to try to factor it. And I noticed that I've got a 4, which is, I can take the square root of, that's 2 squared. So the 4x is really a 2x that you can square. The y squared, that's something squared. So that's good. First and last terms are things we can square or that are squared. The middle I can divide by 2 because there's a 4. I can divide that by 2. And then you want to check, does that then also take the first parts and multiply them together? So this 4x is 2x squared. And then that's y squared. The middle, when I divide that by 2, I get 4 divided by 2 is 2. So I get 2xy. And that 2xy is the 2x and the y multiplied together. So it is the first part and the last part, those multiply together to get you that middle after you divide it by 2. Because you have a 2x and a y, those are the things that are squared. So this is a perfect square trinomial. And so once you recognize that it's a perfect square trinomial, then you can get your answer. So we still have the 3 in front. But the perfect square trinomial starts with your first thing that you squared, which is 2x. Our middle is negative, so we're going to have a minus here. So the middle term stays the same sign as your middle term. The last thing is a y squared, so that's going to be a y right here. And then it's squared. And that is your answer. Because once you have it as something that's linear, where you get down to this point, you can't factor further. And so we end up with 3, and then in parentheses, 2x minus y, and then squared. Are there any questions?
Yes, can you back up just a little bit?
Where do you want me to back up to?
I got lost on the y squared, 2xy, and 2x.
Okay. So did you get lost on how, oh, the part that's in white?
Yes.
Okay. So that is me checking to see that it matches our formula to see if it's a perfect square trinomial. So if it's perfect square trinomial, it needs to be in one of these forms. And I'm looking at the bottom one because that one is a minus. So the first thing is something squared. So 4, I can get from squaring the 2. And x is, when you square it, gives you x squared. So that's where the 2x comes from. Then the y squared is literally y squared. And then the middle says -2. So I factored out a -2. That middle that we have here is -4xy. And the middle that we have on the formula is -2ab. So I need to see if I can divide it by a -2. So I divided out a -2 from -4, and that left me a 2 left over. And then I still have my xy. So the -4xy, when you divide it by 2, gives you -2 and then a 2xy. And then our formula says that's a times b, or the first thing squared times the last thing squared. So 2xy is equal to the 2x times the y. So it is equal to your first thing times, the a and the b, those match. So I'm verifying that it follows my formula. And then once you've verified it's followed the formula, then this is your answer here. You put it in this form. So the thing that was squared is first. So that's where I got 2x here. And then it's minus the last thing that was squared, which is y. So that's where it's -y. And then it's got to have a minus there and it's squared.
Okay, thank you.
You're welcome.
I had a question.
Mhm.
So for the one that says that, so for the first one that says factored or prime, if that appears on the test and we just put prime, or like the quiz or whatever, we just put prime, we would still get that wrong. We would have to do the factored part, or could we just put prime?
It's not prime. The original thing is not prime because we factored out a 2.
Okay.
The part in parentheses is prime. We couldn't factor that part forward or further, but the whole thing that we were asked to factor is not prime because we could factor out a 2. So if you put prime, that would be incorrect because you did factor something out. You factored out the 2.
Oh, okay. Thank you.
Mhm. That's actually a very common thing that people get wrong on the quiz. So it's a good question to ask. And that's actually why I wrote the word factored, to make it clear that yes, this has been factored.
Yeah, I feel like when I saw that, I was about to, on the test, something similar to this, I was going to put prime. And I think I actually did, and I think I got it wrong.
Yeah, because it's like, even if you can't go further, if you can take any number out of that, then automatically it's not prime.
Okay, perfect. Thank you.
You're welcome. Other questions? Okay, so these are my last 2 examples. And these are both a little different because the exponents are not x squareds, they're to the 4th. But these are still in the form, and I'll show you how. So first one, we have 16x to the 4th minus 24x squared y plus 9y squared. So first you look to see if there is a number that you can divide out of all 3 of those numbers. And there isn't, because while I can divide 4 and 8 out of the 16 and the 24, I can't divide those out of 9. And there's no variable that I can remove because the first term has x, middle term has both x and y, and the last one has y, but they don't all have the same combination of variables. So then we see, we check, is this a perfect square trinomial? So the 16x to the fourth. So 16 is 4 squared. So I know that if I square the 4, it will give me 16. And then what happens with even exponents is you can tell it's a perfect square if you can divide the exponent by 2. So the exponent here is 4. If I divide that exponent by 2, I get x squared. So this is actually equal to x squared squared. Because when you multiply, when you have an exponent on top of another exponent, you multiply them together. So this is something squared. So if you see an x to the fourth, it is something squared with that x to the fourth. It's x squared squared. Then my last term here, we've got this plus 9y squared. So 9 is 3 squared, and then y is, of course, or the y squared is y squared. So that is 3y squared. So the first part of the perfect square trinomial, we fit, you know, and that's the first thing you check, because if it doesn't fit that, then you don't even bother in the middle. Next is to check that the middle can be divided by 2. So our middle we have is negative 24x squared y. So when I divide 24 by 2, you get 12. So I can factor out a negative 12 in this, or a negative 2, and this could be 12x squared y. So that's so far so good, that we know that the middle term can be divided by 2, because that's one of the requirements. And then the other requirement is that that middle term, after you divide by 2, is made up of these two other parts. So if I take 4x squared and multiply it by 3y, do I get 12x squared y? So 4 times 3 is 12. And then I have an x squared y, and I do. So the first part and the last part, when I multiply those, I do get that middle. So that means that, yes, this is a perfect square trinomial. So I've just verified that it fits all of our requirements. So once you verify that, then all we need to do is put it in that form. Now that we know that it fits the first part, we can write it in the second part. So it's going to be your 4x, and then it's going to be minus, because the inside, the middle term is minus, and 3y, and then squared. So I went through all 3 parts to verify that this is a perfect square trinomial. The first term and the last term, you square them, you can find what you squared to get them, they're perfect squares. That the middle can be divided by 2. And that after you divide by 2, the middle is made up of the first and the last kind of multiplied together. And so that matches, and then you can get your 4. So even though it was an x to the fourth, that we had these other variables, it still is a perfect square trinomial. Now the one on the right, same sort of deal. And the one on the right is actually easier because we don't have multiple variables. We still have something to the fourth, which doesn't necessarily look like it's something that you can take the square root of, but it's an even exponent. So even exponents you can take square roots of. So if we check that this is a perfect square trinomial, so we have a to the fourth plus 12a squared plus 36. So a to the fourth is a squared squared. So basically whatever your exponent is divided by 2, that's the exponent on the inside part. 36 is equal to 6 squared. So that's good. Inside the 12a squared, we can divide that by 2. So when I divide it by 2, I'm left with 6a squared. And you want to make sure that that comes from the first and last multiplying together. So we've got an a squared times a 6. Yes, that gives you your 6a squared. So this is a perfect square trinomial. And so I can put it in our form. So the first part was a squared. And then we've got a plus this time because the middle is positive. The last one is 6. And then it's going to be squared. So you get a squared plus 6 squared. It can be a little confusing when your formula has the letter A and what you're factoring has the letter A. And so you want to be careful that you're not kind of getting confused between the A's. So sometimes instead of writing the formula as I did in the box, you could kind of do it with color coding. You have something squared minus 2 times something times a different something plus something squared. And so you can kind of, instead of doing, you can color code that you have something squared times, 2 times that something, and then you have a different something that has a different color. So if you color code, like if you get confused with the variables, then you can do that same color coding for your formula so that you can see what numbers go where. So if you have a highlighter, that's a good way to kind of do this as well. If the letters of the formula kind of throw you off, especially if you've got a problem that uses those same letters. Are there any questions?
Yes, I had a question. So on the blue side,
Mm-hmm.
the exponent a squared, how come that one has an exponent and on the yellow side the 4x isn't like exponent?
It is an exponent. It's got a 4x squared parentheses squared.
All right, sorry, I'm just kind of lost.
I
It's
have
the final answer on the bottom because it's 4x minus
Oh,
3y square.
that-
Is it supposed to be 4x square?
that was a typo on my part, forgetting to write that too.
Okay, I was just kind of confused. Thank you.
Okay, thanks. Thank you for clarifying the question there. I didn't know what part we were looking at. All right, other questions? And please let me know if I miss any other things, if I have written something like that. Everybody makes little typos. Like, it's not really typo because I'm writing. Yeah, that's one of the reasons why you guys turn in your quiz work, because you could easily do that on a quiz,
Will you be going over word problems or no?
No.
Oh, okay.
Yeah. This week, there aren't really many word problems.
Oh, okay.
Yes. So you don't really have to worry about them this week. It's mostly an algebra only kind of thing.
Thank God.
Yeah. So yeah, week 1, and then there's word problems again. They show up again on the midterm, and then like week 7 and 8 tend to have word problems show up again. So you'll have some weeks where you won't have to worry about those for a bit. All right.
Sorry, do you know if you have time to go over some of the simplifying absolute values?
I actually have a student that I have to call after this. So
Okay.
not if I gotten done earlier, maybe. But no, I gotta pull up the student's information and everything that before giving a call. But tutor.com. So if you bring open the class. Sometimes people don't realize that there is tutoring. Right, okay. So, under tools and technology here, there's this live tutoring. So if you click that, and this is available 24/7, you get 4 hours every month and it restarts at the start of the month. So this is a good time to make sure you use it up because the month's going to be restarting in about a week. So you have to pick your topic. You want to pick MA105 and then you pick college algebra. And then you can choose whether you want to do a chat or voice. What I recommend doing is taking a screenshot of the question you have and then attaching it as a file because you can't type math into here. So it's a lot easier to take a screenshot and just attach it. But then you click connect now, and then you'll connect with somebody that can help you. So this is completely free for you. And when you run out of the 4 hours, up here, it will say request more time, and then you can click a thing to request more time. Otherwise, you can schedule a tutoring session in advance. And so if we pick, so we've got several people. And so if you know that you're going to need help at a specific time, you can, schedule a specific tutor if you know there's somebody that you really like or something like that. So yeah, if I didn't have another student that I said I was going to call, right after this, I would totally help you with the absolute values, but I don't want that student to be waiting. So. All right.